I did a video a few weeks ago on the new features of C# 11 for checked and unchecked arithmetic operator overloading. And I got a question from a subscriber which was asking about quite a detailed little point on that, but it made me really have to think about what was going on. So I thought it was worth just going through that because it's quite an interesting view as to the way that C# works. So what we had, and do have a look at that earlier video if you don't remember, but basically I put together this little struct called velocity with 3 dimensions of velocity and then given it an operator plus, but because of the nice new features in C# 11 we can overload that to have the checked operator plus and then just the regular unchecked operator plus. And the point is that in the checked version we can put in some kind of overflow check, and what I'd done was put a check to make sure that we hadn't exceeded the speed of light. Now, once again, I'll apologise. Any physicists out there will know this is not how the universe really works, but it's just an example of where we can do checking. Whereas the unchecked version just does the maths and doesn't worry about the overflow. And for debug purposes, we've also put in an unchecked and a checked message that have been printed out just so that we know what's going on. And then the other thing I had there was an extension method where we could take in a collection of some data type t as long as it supports this I addition operators interface, which we can see that our velocity does, and then it basically loops through and adds them all up. And that plus equals will automatically call the plus that we've put in here. But which version will it call? Will it call the checked or the unchecked? Well, that can be determined in a number of ways, but the way I've got it determined here was on the basis of the project setup. So if you look at the project, we can see I've set it up here so that if we've got a debug build, we go for it being checked, and if I've got a release build, we go for it being unchecked. And at the moment we're in a debug build, so if we run this, we can see we get checked called a couple of times as we loop through the list, but that's the version that was being called. Whereas if we switch to a release build and do that, then you can see we're getting the unchecked version, and it's not actually overflowing in either case, but we can see which version is happening. Then the other thing we had was this interface that I already mentioned, this I addition operators interface. Because if we take a look at that, we can see that it's got the unchecked version as a static abstract method, which means I have to provide an implementation in my velocity class. But then we've also got this static virtual, which is the checked version. And because it's virtual, it's got a default implementation of just adding the two together, calling the unchecked version. And so that means that in my velocity, if I miss off the checked version, so let's comment that out, then it will go to the checked version in the base class, call the unchecked version, and so in my class, the unchecked version will be called in both cases. And again, we can demonstrate that because if I run generic maths, we can see at the moment it's a release build, so we'd expect to get unchecked anyway, but even if I switch to the debug build, we're still getting the unchecked version, and that's because it goes through that virtual implementation that we've got down there. I should just point out, the reason I've done it with this extension is because you have to do the addition through the interface. If you did the addition directly on the velocity objects, then it wouldn't bother with the interface as an optimization. It would be able to see what was going on directly and not worry about it. So that's why we have to go through the interface. And it was here that this question came in. It came from a subscriber called Gnul or Gnul, I'm not quite sure how I pronounced that, but it's a really interesting question. And basically it was, well, hang on, how come this bit of code here is not recursive? If we say left plus right, we're inside the checked version, so we must be in a checked context. So why don't we just call ourselves and have infinite recursion and eventually get a stack overflow? And this is the thing I had to think about for a bit. And the way I went about it really was, well, let's try doing this for ourselves. So first step in this sort of thing, let's create our own version of this standard library code. So I'm going to add an interface, call it my addition operators, just to be distinctive. And then we'll copy all of this standard code and pop it in there. Change the name to my, and then also change it on the velocity and also change it on the extension. And then we should be behaving exactly the same way, but not using the standard interface, using our own version of it. And so we should get the same results. Let's have a look at the release build. Let's run that one. And you can see it's doing unchecked both times. Then if we do a debug build, then it's suddenly changed behavior. We've got a Stack Overflow error, and we've got Stack Overflow saying it's gone down 10,705 times, so deep down the stack, run out of space. Even though the code looked exactly the same, it was behaving differently. And in fact, if we go to our my addition operators, and let's just put that on a separate line so we can see what's going on, put a breakpoint on there and run it, we can see we hit that breakpoint. If we look at the call stack, we can see we've gone down one depth, but each time we go around there again, we can see the call stack just getting deeper and deeper. It's doing exactly what the question was about. It is calling itself, and we're getting infinite recursion. Now, the solution, the obvious solution, is pretty simple. All we need to do is this. We'll turn this into a regular function rather than having the expression body member. And then we'll take that left plus right and we'll put it in an unchecked block. So now, although we're in the checked version, it itself is an unchecked block, and so we'll call the unchecked version. And if we run that, then we'll see now it's working okay. So in the debug build, so we start out checked, but then we explicitly switch to unchecked, and it's all working fine. So it's not a difficult problem to solve, except for this one fact that in the actual standard library code, it didn't need to be solved. It wasn't there at all. So although you can get around it, we've still got the question, why does that code that we've got there work without having that switch from checked to unchecked? And the reason is, fundamental thing about the way that checked and unchecked that we have here works is it does not cascade. Let me show you what I mean by that. So let's stick with the debug build. So the default setting is checked, but let's go to the program and put that sum in an unchecked block. Okay, so although the default for the program is checked, that's now unchecked. Let's also just remove the unchecked here, just so we'll see whether the error is occurring or not. And let's run that. And again, we're getting the overflow. And the reason we're getting the overflow is because obviously this version is being called, and that's where it's recursing. But if we look at our program, we've put that in an unchecked block. But the thing about unchecked, as I say, it doesn't cascade, so it only applies to code directly inside there, but still within the program file that we've got there. If we wanted to make some unchecked, we'd have to explicitly put that in there. So we'd have to, in here, put an unchecked block. And that would mean that this plus equals, which is using the plus, is now inside there. And so now when we run that, it works again fine. So that's the key thing that's happening. And so that's why, regardless of what you have at this level, anywhere else, unless you explicitly put it in there, it's going to use whatever the project setting is. And that's why my addition operators was failing, because it was using the project setting, which was checked, and therefore it was calling itself. Easy to solve. Rather than having to put in that unchecked block in there, let's just add a library. We'll call this my interfaces. We'll add a dependency from the program onto that library. And just have a look, you'll see that by default, we don't have any of that stuff we had here about whether it was going to be checked or unchecked. So it defaults for the library to always being unchecked. And then if I take that my addition operators, drag it into the library, we can get rid of that class 1 and also get rid of the original. And so now the code should still be working okay, but we're now referencing this interface in a different library, and that library is being built as unchecked. And so now when we run it, even though this is checked, even though we've not got anything in there, and indeed let's remove that there as well. So everything in the generic maths library is going to be running as checked. When we run this, we don't get the Stack Overflow because the actual plus in here is being run unchecked. And so although it comes in as checked because it's being called from our library, which is checked, its own library is unchecked, and so this one calls the unchecked version, and everything works okay. And of course, that's what was happening with the actual original interface. So when we had a look at this one here, that code is built unchecked, and so that's why the checked version always calls the unchecked version. So quite a simple, really quite obvious once you think about it, answer to what's going on, but you've got to spot the fact that checked and unchecked don't cascade, they only apply to code directly inside them. So nothing's going to really change your way of programming C# there, but it's an interesting question. Thought it was worth answering. So I hope you enjoyed that. If you did, do subscribe, do click like, and I'll see you next time.